Hi, this is our ME351 project presentation. We're going to talk about our line following egg carrying robot. My name is Margaret Thompson, and we also have in our group Sommer Scott, Jack Douglas, Ethan Hanson, and Alex Aldes, who was unable to be with us today because of circumstances very out of his control. So first, I'm going to go over the contents of our presentation a little bit. So we're going to talk about the electronic measurement and probability and statistics and engineering, signal conditioning, computer interfacing, transducers, actuators used in our design, our system design, system implementation, and teaming fundamentals. And it's important to note that these are the ABET requirements for this class, so we are working very hard to cover them. So first off, we're going to talk about the basic methodology of electronic measurements and how our project works to accomplish that. So we have a line following robot concept, and this implements some of the very important basic methodology of mechatronics. First off is that it measures data on position and distance, and then it responds to that data. So it filters the incoming signals and smooths them out and makes sure any outliers are aren't controlling it, that it's the true data. And then it uses an algorithm that we wrote to determine the output of the actuators to achieve the desired results, which in this case is following the line while not dropping the egg.
So as Margaret previously mentioned, that we had some signal conditioning. The way that we were able to smooth out some of our signal was to apply a moving average. Our moving average took the previous 4 points and averaged them to create an average. This smooths the input from the line following sensors and helps filter out noise. So in order to perform basic interfacing, we use the provided Arduino Uno controller. This is something we were all familiar with based on previous ME coursework. It receives analog input from the line following sensor and ultrasonic sensor, and it sends out digital input to the motors and also the LCD. We had to select a transducer as part of this class. We chose to use the line following sensors used in lab to avoid purchasing extra parts. The line following sensor was purchased from DigiKey, and it works by measuring the reflectivity and the surface directly below the sensor. This allows the robot to tell if it is on the dark colored line or if it is off the line on the white colored floor.
To choose an actuator for our project, we went with the hobby gear motors that'll power our robot. These can be purchased from SparkFun for about $4. And they're a very inexpensive option for getting our robot rolling. They require an input of 4.5 volts and 190 milliamps, and they can get a wheel speed of up to 140 RPM without load. So when it came to designing our final project, we first went about brainstorming with a few different ideas for our object. So we had a line following challenge, a climbing challenge, or perhaps a object moving challenge, and we ultimately voted and went with the line following option. From there, we established a flow chart to get the basic process of what a robot needed to do established. And then from there, we started simulating. We set up the wiring for the robot in Tinkercad. And lastly, we started a schedule to make sure all the tasks that were required to complete the robot were set to individual members so everyone could contribute.
So implementing the mechatronic systems into a final robot, we used code, used data from the line following sensors to control the drive motors. We wired sensors, motors, and the other components to the Arduino. Then we attached all the components to the chassis, and then verified that the robot worked, tweaked some code, and yeah. And finally, working as a team, we all voted on the project ideas. The team leader assigned weekly tasks to members, and then handled accountability issues to keep the team moving forward.